Yeah, I know you get some of these questions that are just so diabolical. They start all mellow on you and then they just get out of control, like the movie Parasite. So what you got here is something where you've got to do first principles, but when you start it off, it seems pretty okay. So the first bracket that you see, you're just going to go x plus h and minus the graph that you've got. So that's all just quite a standard procedure. And then when you try to get further, it just immediately feels like you got nothing to cancel there, bro. And I'm going to teach you one of the most trippy things you will ever see in the high school syllabus. I'm going to rationalize the numerator. I'm going to take the numerator and just say, how's it, my britchie? I'm going to do exactly the same as I see there on the numerator, but I'm just going to swap it around. I know that it's pretty whack, but you got to trust, bro. You got to trust sometimes. You ask, why do you do that? Why do you do something so trippy? The reason, my bro, is that if I do the exact same terms the opposite way around, then I've got a difference of squares. And so when I do that, a root times a root would just give me what was inside, minus a root times a root will just give me what was inside. The middle terms will both cancel because you've got a minus version and a plus. And on the bottom you've just got the LCD, which is that H, and the other sick bracket over there. Now the problem with first principles is that you can't just cancel and make the H 0 straight away, because if you do that, it's undefined, which means what the stuff's happening, things aren't working out, and so you can't cancel, so you got to do some other stuff. Let me just pause this video. I just got so excited with this trippy trick here that I forgot what I normally do. What I normally do when I see a question of first principles is I just, on the side of my page, I just dream a bit. Just go to a safe place where you do first principles the really simple, easy way. Change the square root into a power of a half times the power by the front and drop the power by 1. Standard procedure. A negative power just goes to the bottom and the 2 is at the bottom, so that would just become a positive power. And that, if this was a baby question, that is right for derivatives, but you can leave it like that. You say, why do you do that? Why do you do that, little guy? To make my life easier and also to know where I'm heading. You want to know where the journey's going, otherwise everything's a bit aimless. And so here, back to the question again. The x minus the x, they gone, so I'm just left with the h on the top. And if I just have h, then at this point now I can cross the h with the h. Don't forget, don't have nothing on top, you still got a 1. You got to put something there, buddy. You can't just leave it all out. And so what we've got there is 1 over this razzmatazz on the bottom. And at that point, once you don't have just an h on the bottom, you can let h equal 0. And if I let the h equal 0, all I've got is just a root x plus a root x, which is just 2 of those. Just think of a cookie and a cookie, and you've got 2 cookies. So what's my final answer? It's just 1 over 2 cookies. It's 1 over 2 root x. What was I meant to get when I was checking out this whack question? In its simplest form, I was meant to get 1 over 2 root x. And just like that, we've done a bodacious trick of doing something utterly trippy and doing and rationalizing the numerator. Unbelievable. unbelievable. Excuse my excitement there. If you found that unbelievable, please share this with your brute cheese. Subscribe to this gnarly channel and enjoy the rest of the videos.